theta 2 gives us scattering angle. angle. So this gives the perfect reading of the scattering angle. And now if we talk about the wavelength, as I stated that zero point 0.1 nanometer of wavelength is scattered by electron shell of atoms. If X-rays are scattered by a crystal, the diffraction may be regarded as the reflection of X-rays from the crystal lattice plane, and a formula is given for which, and which is the number of wavelength with wavelength itself gives twice of d distance with sine theta, which is an angle itself. So here, if X-rays are scattered by a crystal, the diffraction may be regarded as the reflection of X-rays. The diffraction of X-rays is observed in the if the scattered waves are in phase. That is, the difference in distance traveled by rays is equal to an integer n of wavelength, which is here given n of wavelength. The integer, we can take it as any reading. Okay, so after it, if we say that if the distance between the reflecting crystalline planes is d, the distance, the interplanar spacing, the condition for diffraction is given by the Brake's equation. And here finally the Brake's equation is given. This Brake's equation finally states the number of the number, whether it would be an integer, wavelength equals to twice of distance with the sine theta, that is the angle which is projected on this smooth plane. So here are some important points regarding X-ray diffraction. So X-ray diffraction is usually recorded on photographic film. Photographic film, which is used to show the X-ray diffraction. It is widely used by the scientists and the researchers who research on the diffraction of X-rays. But ionizing, but major factor is but ionization methods of recording are much more accurate and sensitive on this photographic plane. So these are much more effective and accurate. So photographic film is used for this, and diffraction maxima are various intensities. Analysis of diffraction pattern enables one to derive the electron density distribution in a crystal, and the electron density is expressed through so-called structure amplitudes, which depend on the number of electrons in the atom. So if we take for an example, this is electron, and okay, this is an electron. Then in outermost shell, they whether it would be 2 or 3 valence electrons with an inner electron of 2, and outer would be 3, and for it it will give the 3 electrons to stable itself as an electron shell. So these 3 electron valencies, when light would be projected on this electron, then this will give 3 electrons to stable or stabilize itself, and these 3 electrons will give the color and the scattering phenomenon of the X-rays, which is called as X-ray scattering solution of biopolymers, or diffuse scattering of X-rays by solution of biopolymers. So what do we mean by biopolymers? That biopolymers are actually the diffuse scattering of X-rays by solution of macromolecules yields direct information on the distribution of scattering objects. The macromolecules, whether it would be it would be the shape of cylinder, or whether it would be a total scattering by randomly arranged individual macromolecules, for which the reason of scattering light intensities are averaged over all possible orientation of the macromolecules. The Larger the angle, if the larger the angle is, if we take this as a surface plane, we project we project here light, and it is reflected. So